As a geographer, the most pertinent question is, do earthquakes occur randomly on the Earth's surface, or do they have certain visible distributional pattern? Generally, we hear that certain earthquakes are categorized as less or more intense. Then what basis is the earthquake called as low or high magnitude earthquakes, and so on. With these questions in mind, the main aim of the lesson is to know how the intensity and magnitude of the earthquake is measured, to understand the world distributional pattern of earthquakes, to analyze the consequences of earthquakes. Magnitude is the amount of energy released by an earthquake. The magnitude of the earthquake is measured on Richter scale. The Richter's magnitude scale measures the amount of seismic energy released by an earthquake. When an earthquake occurs, its magnitude can be given a single numerical value on the Richter scale. The Richter scale is related to the energy released at the earthquake center, and thus can be used as an estimate of the severity of the particular earthquake. The Richter scale is open-ended, logarithmic, that is, each whole number on the scale represent 10-fold increase in the measured wave amplitude. The vibrations of an earthquake with a magnitude of 2 are 10 times greater in amplitude than those of an earthquake with a magnitude of 1. The damage caused due to the earthquake is directly proportional to the magnitude. The energy released by an earthquake is measured in terms of ergs and joules. The energy released when the earthquakes occurs is measured in terms of magnitude of the earthquake. The factors contributing to the quantity of energy released depend upon 1. Duration of the earthquake, and 2. Depth of the focus. The duration of most of the earthquakes is few seconds only. The duration of very few earthquakes exceeds 1 to 2 minutes. The energy released by an earthquake is directly proportional to the duration of the earthquake. That is, if the earthquake lasts for a longer duration, the energy released is more. The depth of the focus of an earthquake plays a significant role in the release of the energy. The intensity and the magnitude of an earthquake is greatly depends on the depth of the focus of the earthquake. Shallow focus earthquakes are associated with less intensity and magnitude. The severity of the earthquake is assessed using a descriptive scale, modified Mercalli intensity scale. The scale is based upon the damage caused to structures and the life by an earthquake. The intensity is destructive power of the earthquake. The damage to the property and life is more near the epicenter and decreases gradually away from the epicenter. The intensity of the earthquake also depends upon the compactness of the underlying ground. The damage caused by the earthquake is directly proportional to the magnitude of the earthquake. The intensity and magnitude of the earthquake also depends upon the depth of the focus and duration of the earthquake. The seismographic records of the earthquakes helps us determining the intensity of earthquakes at various places and their time of occurrence. Lines drawn through the places experiencing the same intensity of earthquakes are called as isosysmal lines. Lines drawn on the maps joining places experiencing an earthquake at the same time are called as homosysmal or co-sysmal lines. The map showing the distribution of earthquakes reveals that they are concentrated in certain zones. Earthquakes are mostly associated with the weaker and isostatically disturbed areas of the world. Most of the world's earthquakes occur in 1. The zones of young fold mountains, 2. The zones of faulting and fracturing, 3. The zones representing the junction of continental and oceanic margins, the zone of active volcanoes, and next one along the various plate boundaries. Most of the earthquakes are found in the following belts: 1. The Circum-Pacific Belt, 2. The Mid-Oceanic Belt, 3. The Mid-Continent Belt, and 4th is intraplate seismicity. This belt is associated with convergent plate boundaries where the Pacific Oceanic Plate is being continuously subducted below the North and South American plates. The earthquakes associated with eastern coastal margins of Asia and island arcs like Kamchatka, Sakhalin, Japan and Philippines are caused due to the collision of Pacific and Asiatic plates. Besides, these zones are also the areas of volcanic activity. The belt presents 4 ideal conditions for the occurrence of earthquakes, such as junction of continental and oceanic margins, zone of young fold mountains like Andes and Rockies Mountain in North and South America, zone of active volcanoes, and subduction zone of convergent plate boundaries. The Circum-Pacific Belt completely encircles the Pacific Ocean. This belt accounts for 65% of the total earthquakes of the world. On the eastern side of the Pacific Ocean, the earthquake zone follows North America and continues southward along Peru-Chile Trench on the western coast of South America. This belt is associated with extensive volcanic activity. It is also known as Ring of Fire. This belt extends along the mid-oceanic ridges and several islands near the ridges of Atlantic Ocean. This belt is also called as Mid-Atlantic Belt. The belt is associated with divergent plate boundaries. Earthquakes of moderate to mild intensity with shallow focus less than 70 kilometers deep are associated with this belt. The belt is also called as Mediterranean Belt or Alpine Himalayan Belt. Nearly 21% of the total seismic events of the world are recorded in this belt. The zone represents the collision and the subduction zones of continental plates. This belt includes Alpine Mountains, Mediterranean Sea, North Africa, Eastern Africa, Asia Minor, Iran, Afghanistan, Pakistan and Himalayan mountains, including Tibet, the Pamir, Tian Shan, Altai and Myanmar hills. In India, the Himalayan region is a zone of maximum intensity in terms of the magnitude of seismic tremors, because this zone is located in the subduction of the Asiatic and Indian plates. The impact of earthquakes are determined not on the basis of the magnitude of the earthquakes, but are decided on the basis of quantum of damages caused by the earthquakes. to human lives and property. An earthquake becomes hazard and disaster only when it strikes the populated area. The direct and the indirect effects of the earthquake includes landslides, deformation of the land surface, loss to human property and lives, fires, flash floods and tsunamis. The shocks produced by the earthquakes, particularly in hilly and mountainous areas, cause landslides. In the young fold mountains like Andes, Rockies, Alps and the Himalayas, earthquakes result into landslides which damage the human settlements, disturb the transport system. The earthquake in Peru in 1970 resulted in collapse of ice caps on the high peaks of 𝗂𝗽𝗱 6654 meters near the town of Yungay. It is not the intensity of earthquake alone which matters more as regards to human casualties, but it is the density of human settlement which matters more in terms of human death. It has been estimated that on an average about 15,000 people are killed every year by the earthquakes. The Kangra earthquake of India in 1905 recorded 8.0 magnitude on Richter scale, but caused death of only 20,000 people, whereas more than 40,000 people lost their lives in the devastating earthquake of Turkey in 1999. Earthquakes cause great damage to the buildings, roads, railways, dams, bridges, etc. Disastrous earthquake of Mexico City of 1985 caused total collapse of about 400 buildings and damage to 6,000 buildings. Moreover, water supply system was severely damaged. The vibrations caused by the severe earthquakes strongly shake the buildings, and thus strong oscillations cause severe fires in houses, mines and factories. Because of the overturning of the gas cylinders, contact of live wires, damage to the blast furnaces, displacement of electric and fire related appliances. For example, in Tokyo in 1923, severe fire broke, out of which 38,000 people out of total fatalities of 1,63,000. Under an impact of severe earthquake, sometimes the dams and the embankments develop cracks or fissures, which becomes cause of flash flood. Severe floods are caused because of the blocking of flow of rivers. Sometimes the blockade of rivers is so immense that even the main course of the river is changed. In 1950, earthquake of Assam produced barrier in the Dihang river. Sometimes earthquake vibrations caused by the severe earthquakes result in the deformation of the ground surface because of the faulting, which leads to the subsidence and rise of ground surface. The ground surface was greatly deformed in the delta area of the Indus River, which is located in Pakistan, due to the earthquake in 1819, due to which an area of 4,500 square kilometers was submerged below water and disappeared forever. Is one of the main consequences of the earthquakes, which damage buildings and other structures on the ground. Ground shaking is the destructive force that results when the energy is released by the earthquake, during its travel along the Earth's surface, making the ground vibrate up and down as well as from side to side. Structural damage due to the shaking depends upon the intensity and duration of vibrations, distance from the epicenter, geological and geomorphological conditions of the area, and design of the structure. Another consequence of earthquake is the ground rupture. It is the breaking and displacement of the Earth's surface along the fault plane. Soils which are very loose or sandy in nature, such as alluvial and sandy soils, may not withstand the impact of earthquake. When granular soil like sandy soil is saturated with water temporarily, it loses its strength and transforms from solid to liquid state. Soil liquefaction is the state of ground failure during earthquakes. As a result, structures like buildings either tilt or sink liquefied soils. During 1964 Alaskan earthquake, soil liquefaction caused sinking of several buildings. During 1964 earthquake in Niigata in Japan, due to liquefaction, several buildings leaned and toppled down sideways. Tsunamis is a Japanese term for the high seismic wave that travels through the ocean and seawater. Tsunami approach can be indicated by sudden retreat of seawater away from the shore, followed by an earthquake. After some time, retreat of the water is followed by a strong surge with great heights. In deep waters, tsunami is not a threat because they are very broad with large wavelengths and less height. When the tsunami wave approaches the shore, the depth increases and the energy tends to concentrate in the shallow water. The front of the wave slows down and the wave grows in height and surges the coastal areas. Although in the open ocean, the wave height may be less than 1 meter. It steepens to a height of 30 meters on entering the shallow coastal water. The tsunami that occurred in 26 December 2004 killed about 2 lakh people in Indonesia, Thailand, Sri Lanka, Andaman Nicobar Islands, Maldives, Myanmar and Tamil Nadu in India. Based on the spatial distribution of earthquakes in India, it is seen that earthquakes in India mostly located in the Himalayan mountain belt. The Indo-Gangetic plains, which are located at the foothills of Himalayan region, is mostly affected by the earthquakes originating in the Himalayan region. But changes appear to be still taking place at the bottom of the Gangetic trough, giving rise to the occasional earthquakes. The Sindh earthquake of 1819 and Bihar earthquake of 1934 had their foci in the trough covering Indo-Gangetic plains. The peninsular parts of India, which mostly covers South India, is considered to be stable block. That is, the peninsular India is considered as a free zone from seismic activity till recently. Occasionally, however, some earthquakes are felt along the margins. The Koyna earthquake of 1960 and the Latur earthquake of 1993 are the major seismic events which occurred in the peninsular India. The Gujarat earthquake that occurred in January 2001 recorded 8.1 on the Richter scale, 20 kilometers northwest of Bhuj. According to the seismologist, The 𝗪𝗃 earthquake is caused due to the reactivization of 𝗂𝗏 fault. The reactivization of the fault was due to the movement of Indian plate northward. The Indian plate is moving in a northwest direction at the rate of about 5 cm per year against the Eurasian plate along the Himalayan ranges. The Bureau of Indian Standard, that is BIS, in the year 2002 divided the country into 4 seismic zones based on the past seismic history. These seismic zones are categorized as Zone 2, Zone 3, Zone 4 and Zone 5. Zone 5 is the most seismically active region, whereas Zone 2 is the least seismically active zone. The Zone 5 comprises the entire Northeast India, parts of Jammu and Kashmir, Himachal Pradesh, Uttaranchal, Rann of Kutch in Gujarat, parts of North Bihar and Andaman Nicobar Islands. Zone 4. This zone covers remaining parts of Jammu and Kashmir, Himachal Pradesh, Union Territory of Delhi, Sikkim, Northeast Uttar Pradesh, parts of Bihar, West Bengal and Gujarat, and some parts of Maharashtra near west coast and Rajasthan. Zone 3. This zone comprises Kerala, Goa, Lakshadweep Islands, remaining parts of Uttar Pradesh, Gujarat, West Bengal, parts of Punjab, Rajasthan, Orissa, Andhra Pradesh, Tamil Nadu and Karnataka. Zone 2. Zone 2 covers remaining parts of the country. The thickly populated areas such as towns and cities identified as per BIS standards include Bhuj in Gujarat, Darbhanga in Bihar, Imphal in Manipur, Guwahati and Jorhat in Assam. These urban areas fall in Zone 5, which is characterized by very severe seismic activity. Earthquakes is an endogenetic process and is one of the major catastrophe and may cause lot of damage to the lives and property. The damage caused due to the earthquake is directly proportional to the magnitude of the earthquake measured on the Richter scale. Spatial distribution of earthquakes in the world revealed that they are mostly concentrated in the circum-Pacific belt and mid-oceanic belt and mid-continental belt. The effect of earthquakes includes landslides, loss of lives and property, flash floods, ground rupture, tsunami, etc.